Well, good afternoon. We're team number 4. My name is Eduardo Sanguino, Ignacio Perez, Damián Muciño, Andrea Fernandez, and Susana Calderon, and we made an experiment to obtain the frequency using a guitar string. Here come the details.
For the theoretical part, our objective is to find the frequency of 82.41 Hz, which is equal to the note E2. The data that we have is that the mass of the string is 3.9 grams, the length of the string is 37 centimeters, and the mass that we will use to obtain the tension in the string is 3.5 kilograms. If we multiply this mass times the gravity, we obtain the tension, and it's equal to 34.335 newtons. Then if we divide the mass of the string over the length of the string, we obtain the mu, and which is equal to 0.0105.
To obtain the theoretical frequency, what we use is the formula of frequency equals to 1 over 2 times length, and that times the square root of tension over mu, and that as an answer give us 77.3 Hertz. For that, we compared it to an experimental frequency that was 80.7 Hertz. To obtain that frequency, we use this system that includes a microphone to increase sensitivity and a sonogram to prove the tension we use. So, for the system, we attach certain weights to increase the tension of the string until we find the one that was closer to the expected frequency, and to prove it, we played it, which give an approximate of 80 and 82 Hertz. That was being affected because of the harmonics provoked by the surface. But overall, we decided to use a frequency of 80.7.
We obtained a percentage of error between the theoretical frequency obtained and the experimental. And the formula to obtain the percentage of error is the theoretical minus the experimental over the theoretical, all of that multiplied per 100. And the percentage of error obtained was a 4.4%. And we also compared the objective frequency, which was 82.41 Hertz, versus the theoretical frequency obtained. And the result was 6.2% of error.
Now, in order to obtain the 6.2% percentage of error, we needed to compare the experimental result with the theoretical one that we find on the internet, that it gave us 82.41 Hertz. Now, using our data, we equal this to 1 over 2 times the length of the string, that it was 0.37, and then we multiply it to the root square of the tension over the linear density. Now everything gave us the answer where we would take the 6.2% of error.
So we also take the ideal mass from the website that was 3.6 kilograms. In order to take out the ideal tension, we multiply it times 9.81, that is the gravity force. Now the ideal mu, we take it out of this formula. So then with the linear density formula, we take out the mass from the string and give us 0.37 times 9.45 times 10 to minus 3, and it gives us 3.5 grams for the ideal mass of the string.
This experiment, we use the node E2 that was half of our frequency that we are about to use for our new node E3, that is 164.811 Hertz. Now, using our formula of frequency and our previous data, with the new frequency, we took out the length of the string. Now, this is the theoretical part that it gave us 173 meters. This is the theoretical. For the experimental, it gave us 0.70. So the percentage of error is 0.003 meters. So it was a success.
Thank you very much for watching our physics experiments.